Okay, so this question is asking to um, solve this differential equation dy dy over dx is equal to x times the square root of x minus 6. Here, you can use u substitution and make u equal to the square root of x minus 6. If you square u, you'll get that is equal to x minus 6. And you can rewrite it to have what x equals, u squared plus 6. So here we have that dx over du, so we're finding the derivative of this with respect to u is just equal to 2u, and then this constant the derivative is 0. So dx over du is equal to 2u, and then times du, and you have dx is equal to 2u du. Now we can get the integral of x, which is equal to this, times u, which is equal to this, and then dx, which is equal to this. And you can move the 2 over because it's a constant, and then you just distribute the u squared to the u squared and the 6 to the u squared. You should get this. You use n plus 1 over n plus 1 to get the derivative. And then you just replace u with the original square root of x plus 6. Here's to the power 5, here's to the power 3, and then plus c. Okay, so this problem is asking us to solve the differential equation dy over dx is equal to x plus 3. This one's pretty easy. You just use separation of variables and you multiply both sides by dx. Now you have dy is equal to x plus 3 dx. You integrate both sides. The integral of the derivative of y is y, and the integral of x plus 3 dx is just x squared over 2 plus 3x, and then plus c. So this question is asking us to solve the differential equation dy over dx is equal to x times 1 plus y. So again, here you use separation of variables, and you can divide this side by 1 plus y, divide this side by 1 plus y, or times 1 over 1 plus y. And then to get rid of this dx, you just multiply by dx on both sides, and you should get 1 over 1 plus y dy is equal to x dx. Then we integrate both sides. You use u substitution for this side, where u is 1 plus y, and then du is dy. You get the integral of 1 over u du, which is ln u. You replace u with 1 plus y, and you have ln 1 plus y plus c is equal to, and then the integral of x dx is just x squared over 2 plus c. Now you can reduce this by putting both of these expressions to the power, or e to the power of both of these expressions. E to the power of ln 1 plus y, the e and the ln cancel out. You're left with 1 plus y is equal to, and then e to the power of x squared over 2 plus c. You can drop the c as a coefficient multiplied in front of e. You have 1 plus y equals c e to the power of x squared over 2, and then you subtract 1 on both sides to get that y is c e to the x squared over 2 minus 1.